Students, in the previous session, we see the definition of Fourier transform. Let me review this definition for you. For any f in L1 of R, the Fourier transform of f is the function f hat from R to C defined by this. F hat of integral of f of x multiplied by this exponential function. Okay? And we see this example, Fourier transform of this characteristic function equal to this, and also we see this example, the Fourier transform of this function equal to this, and we see the Riemann-Lebesgue lemma that say, suppose f belong to L1 of R, then it uniformly continues on R. F hat is uniformly continuous. Furthermore, the infinity norm of f hat is less than one norm of f, and this limit equal to 0. Limit of f hat of t when t tend to minus or plus infinity. Okay? This equal to 0. And we said in previous session is this proposition that if we consider g of x equal to x f of x and g belong to L1, then we have this equality. Okay, we have this equality. Now we have another example. This function equal its Fourier transform. Sorry, let me a minute. Hello. Okay. The Fourier transform of this function equal to itself. Okay. Suppose f defined by this function rule, then the function g from R to C by this function rule, g of x equal to x f of x, or x multiplied by e to the power of minus p x to the power of 2 is in L1. Hence, by the previous proposition, prime of t equal to minus 2pi this integral, because we have this equality. Okay, f hat prime of t equal to minus 2pi g hat of t. And this is our function g, and this is g hat of t by the definition of Fourier transform. Okay, but this equal to this by the integration by parts. Let me write this for you. Okay, dear students, do you have my voice? Okay. You see that? F hat prime of t equal to minus 2pi g hat of t, and this is equal to minus 2pi g hat, and this is our g hat. This integral x e to the power minus px2 okay. Oh, and we have this x fx, okay. But this is equal to if we consider if we denoted this by a star, we know that the integral of u dv equal to uv minus the integral of v du. Okay, you know this. And its proof is very easy. You know this. Now if we consider u equal to this function minus 2pi tx and x e minus px2 equal to dv, then the integral of this integral x e minus p x2 e minus 2p itx dx equal to this integral dv, okay, u dv, and this is equal to uv, and this is all uv, equal to uv minus this and this integral v du, but from this we have du equal to minus 2 pit multiplied by e by this power itx. If you consider this as u, this is du, okay, du, and also v equal to this minus 2p e minus px2 equal to, because the derivation of this equal to this, okay. So if we denote this by I equal to, this is all I, okay, I equal to uv minus 1 2p e minus px2 multiplied by u e minus 2p p itx and minus this integral v du. This is our v, my 2p e minus px2 du minus 2p it e minus 2p minus 2p itx dx. Okay, so it is equal to minus 1 divided by 2p epx2 tx, and these 2 minus omitted, minus 1 2p and this 2p, so that we have minus it this integral minus px2 minus 2p itx dx, so that this is equal to minus 2pi multiplied by this, and this equal to this multiplied by this equal to I. Okay, I e px2 e minus 2p itx and minus 2pi must be multiplied with this, and we know that I to the power of 2 equal to minus 1, so that this is equal to minus 2pi e minus px2 minus 2p itx dx, so that we have this equality f hat prime of t equal to minus 2pi to this integral, and this equal to these two sentences, and we must compute this from minus infinity to plus infinity. Okay, sorry, okay. minus infinity plus infinity is minus 2pt, 2pt, okay, and this is equal to 0, so that this equal to integral, and this integral equal to f hat of t is equal to 0, so that this is equal to minus minus 2 pt in this integral. This is the integral equal to f hat of t. So we have this equality, f hat prime of t equal to this, and f prime of t equal to this. This is very easy, because f of x equal to this function, so that f prime of t equal to this, or minus 2 pt f of t. In this equation with this, with this equality, we see that the derivation of this fraction equal to f of t, f hat prime of t, f prime of t, f hat of t divided by f of t to the power of 2. And compute f hat of t, f prime of t, and f hat prime of t, okay, and this equal to 0, so that this derivation equal to 0 for all t. Thus f hat divided by f is a constant function. In other words, there exists a constant c such that f hat equal to cf, because this is equal to 1 c, okay. To evaluate c, note that f hat of 0 equal to this. If we consider t equal to 0, okay, f hat of 0, we must consider t equal to 0, so that all of this equal to 1, and or by the definition of f hat, we see that, let me write for you, f hat of 0 okay, f hat of 0 equal to this integral. We use the definition of f hat directly, okay? f hat of 0 equal to f of x e to the power of 0, okay? Now we consider this function. We consider this function, okay? F of x equal to this, so that f hat of 0 equal to e to the power of minus px2 e by this power dx, or this integral. Okay? One. This is equal to 1. You know this. If we consider, for example, this by 2 star, if we consider, for example, a equal to this integral then a2 equal to this integral multiplied by this integral. Okay? So that a2 equal to e minus px2 multiplied by e by this power minus py2, so that is equal to minus px2 plus y2 dx dy. And this is equal to this integral e by this power r d theta by the polar variable, okay? Polar variable minus P R2 R d theta. And integral minus P to P minus A minus 1 to P E minus P R2 0 R, and this is equal to this limit A by this power minus PR2 plus E to the power this or 1. Okay, R2 P minus PR2 minus P R2. Okay, so that this is equal to 1, and so this equal to f of 0, because f of 0 equal to 1, so that C must be equal to 1, because C equal to f hat of 0 multiplied by f of 0, this equal to 1. Okay, so that f hat equal to f. This is a nice example that the Fourier transform of this function equal to itself. Okay, equal to itself. Dear students, do you have my voice? Thank you, Muhammad. Now we have this proposition. Suppose f belongs to L1 of R is a continuously differentiable function and time of R. Therefore, any t in R, we have this equality. F prime hat of t equal to 2pit f hat of t. Okay, and its proof is easy, because for any epsilon because f and f prime are in L1, because f is continuously differentiable, so that f prime is exists and f prime is continuous. This is the definition of continuously differentiable. Okay, f and f prime are in L1. There exists an element such as a in real numbers such that this 2 is less than epsilon. You know that please note that f prime belongs to L1. Okay, f prime so that this integral is finite. Now since this integral f prime of dx equal to this integral minus this integral we have this limit equal to this limit. This limit. But we know that this equal to this, so that this equal to 0. This limit equal to this integral, okay? So that there exists R0 such that for any A we have this integral is less than epsilon. This limit equal to 0, okay? On the other hand, there exists one element such that f prime of R1 is less than epsilon because if for any x greater or equal a0, we have this equality less than or equal epsilon, then this integral f prime of x dx is greater or equal to epsilon, but it's plus infinity, and this is a contradiction by this equality, okay? This is a contradiction, so that we have an element such that this is less than epsilon, and element by this, so that if we consider so if we consider a set or a1, for example, greater or equal a0, we have these two properties. Then this integral is less than epsilon, and also this less than epsilon, okay? In book, consider a, we consider a1, for example, okay? Now if b be an element greater than a, then f of b equal to this, because we know that the integral of f prime of x dx from a to b equal to f of b minus f of a, okay? So that is equal to this, and this is less than, by triangle inequality, less than or equal absolute value of this, and the absolute value of this is less than this. Integral of this absolute value and the absolute value of f of a, and both of this is less than 2 epsilon by our assumption. Okay, both of this is less than epsilon. So for any b greater than a, f of b is less than 2 epsilon, so that the limit of f of it is equal to 0. F of is less than epsilon for arbitrary large x, so that f of x tends to 0 in infinity. And similarly, we can prove that the limit of f of x when x tends to minus infinity equal to 0. So that it is important to prove that these two limits are equal to 0. Now for any t in R, we have f prime hat of t equal to the integral multiplied by this function dt by the definition of Fourier transform. And this is equal to this. This holds by the integral by part. Okay? Part by part integral. Okay? Part by part integral. Because similarly, it's very trivial because integral of f prime minus 2 pitx dx equal to, if we consider v equal to e minus 2 ptix and dv du equal to this integral dx. Then dv equal to minus 2 pit e minus 2 pitx and u equal to f of x. So that this equal to this integral v du and this is equal to uv minus udv. Okay, so that we must consider part by part integration. So we must write this multiplied by this. Okay, it's very trivial because du dv of dx the derivation of this du or dv equal to minus 2 pi t multiplied by these functions. So that this is equal to f of x multiplied by e minus 2 pi tx minus infinity plus infinity and minus udv or plus 2 pi this integral f of x minus 2 pi tx. Okay, but this is equal to 0 and this is f hat of t, so that 2 pi f hat of t. Okay, 2 pi t, 2 pi t. Okay, 2 pi t, I omitted this t, 2 pi t, 2 pi t. Okay, where the second equality, because we showed in the paragraph above that these two limits are equal to 0. These two limits are equal to 0. Okay. By this observation, we have this proposition that for any f in L1 of R and any two element b and t in real numbers, if g of x equal to f of x minus b for all x, then g hat of t equal to this. And if g of x equal to this, g hat of t equal to f hat of t minus b. And for any non-zero element b, if g of x equal to f of bx, then g hat of t equal to this. Please prove these three statements is very useful for you. Okay, dear students, let me write for you. Okay.
يرجى كتابة إثبات الاقتراح 11.55 وإرساله إلي بالبريد الإلكتروني. يرجى
كتابة. Dear students, do you have any question? By email, Muhammad, please send to me by email. Okay, thank you very much. Thank you for your attention, and we continue in the next session inshallah. Goodbye for now.